everyone. I'm from MLST. My name is Ms. Ho Zian, and I'm going to do a presentation on Autodesk Land Desktop and Civil 3D this morning. But before we go into that, what I'd like to do is give you a background about our company first. MLST is an authorized reseller for both the Autodesk and Discrete products. Now basically, Autodesk and Discrete are sister companies, and Autodesk is dealing with software like AutoCAD and all the AutoCAD related products, whereas Discrete, they deal with the animation products like 3ds Max. So just to give you our company profile, MLST was established in 1992 to venture into the information technology industry. We offer a wide range of products and services for our customers, providing them excellent quality and high value. So we've been in the IT industry for quite long. It's about 13 years this year. And our mission basically is to be a leader in the IT industry, to be a total IT solution for all our customers. We don't want to just sell software. We want to be able to provide you with the hardware that help you set up the networks, and plan the entire infrastructure of the computing system for your company. Okay, this is our organization chart. So we have the managing director and director. For me, you can see at the bottom left, I'm the infrastructure solutions consultant. So this is some of the software which MLST deal in. For example, the Autodesk software, we deal with the design automation, which includes the AutoCAD and AutoCAD LT products, and the civil and infrastructure solutions, which include all the civil engineering products. For example, Land Desktop, previously civil design, even Autodesk Map, we deal with that. Discrete products are things like 3ds Max, which are specific for animation, modeling, and rendering. So besides software, of course, we deal with hardware, because sometimes if we sell you the software and you don't have any hardware that can run the software, it's quite pointless, and you have to go through the trouble of finding another vendor. So we will provide you the hardware as well, like the personal computers. If you're running a network, we provide you the servers. And if you want to get notebooks for your engineers, we can also provide you with them. And all the other necessary hardware to run the entire infrastructure of your company. We also have services, and basically our services cover three main parts: the integration, solutions, and the maintenance. Integration basically is like the proposal stage, where we have a look at what your current system is, and we see, okay, what are your requirements and how we can help you propose a solution which suits your requirements in conjunction with your existing infrastructure. The solutions, of course, is the implementation part, where we provide you the software, we set up your network for you, we set up your computers for you, and we make sure that everything runs smoothly. Maintenance is also very important, because just selling you the software and the hardware and setting up everything for you may not be sufficient. You're bound to go through problems, you need technical support, you need some troubleshooting. Okay? So this is where our maintenance part comes in. So if you have any problems, of course, first we try to help you over the phone or by email. And if it really cannot be resolved, then what we do is we go to your company, we go to your office, and we try to solve it for you. So this is our contact information. Our office is in Jalan Kancil, which is off Jalan Pudu. That's in the Pudu Plaza area, in case you were wondering. Right, so we can visit our website at www.mlst.com.my, and I've given you my card, so you can contact me via email or my handphone number. So this morning I'm going to show you two software. One is the Autodesk Land Desktop, and the other is Autodesk Civil 3D. Now Land Desktop is being phased out by Autodesk, and they're concentrating on Autodesk Civil 3D now. Land Desktop has been in the market for quite a long time actually. It started off as Sofdesk until Sofdesk 8. Sofdesk was a very powerful software for the civil engineering side, doing earthworks, doing road design, doing drainage and all that. In 1999, Autodesk bought over Sofdesk. They integrated Sofdesk with their AutoCAD platform, and they came up with Autodesk Land Desktop. So it's been around since about 99. That will be about 8 software Sofdesk. Yeah. So now so they had the Land Desktop 2000, then 2000i, Land Desktop. Yeah, each time is upgraded. Okay, so the latest version at this moment is 2005. Of course, you're going to release the 2006 soon, but Land Desktop is going to be phased out. It's going to be replaced by Civil 3D, and Land Desktop will be offered as a companion license to Civil 3D. It won't be so on its own anymore. Okay. Okay, as you can see, in case you don't know what Land Desktop is, I'll just give you a brief background about Autodesk Land Desktop. Land Desktop comes integrated with the platform of AutoCAD 2005 and Autodesk Map 3D 2005. So it's basically like a 3-in-1 software. We've got the whole package of all the drafting tools and the functions of AutoCAD, and then you have all the mapping tools as well. Autodesk Map is an excellent software for GIS and utilities management. But this morning I'm going to concentrate solely on Land Desktop. Now I've opened up Land Desktop. As you can see, for those who are familiar with AutoCAD, it looks exactly like AutoCAD. You know, we can do anything we want, like draw lines and all that. Okay. But we've got this new, this is a new workspace on the left side. AutoCAD does not have this. This is a map feature actually. And we're going to use a little bit of this. I'll show you later. Okay, first I'm going to create a project from scratch for Autodesk Land Desktop. At least you can see how it works. So I'm just going to open. Okay, this is my project. I'm going to open 2D points. Yeah. Okay, this drawing 2D points.dwg, it actually is a file which only has text that's supposed to indicate the spot levels. I'm just going to zoom in so you can have a look. So these are all the different texts which indicate the 3D levels of each spot height. A very common problem here in Malaysia is that most consultants receive drawings from the surveyors in this format, where you only get a 2D format. You know, it's just a drawing. Maybe you've got points or just text, but you don't actually have points in your 3D positions. Yeah, the Z values are not there. So that becomes a problem because most software in the market now, you need to have the 3D value before you can run any functions and all. So Land Desktop, you can convert these 2D text into 3D points. I have to admit, it's not a very direct conversion, but it is possible. A lot of users of Land Desktop, they think, oh no, it cannot be done because they can't find any function that says they convert, 2D to 3D, they can't find it. Just because it's not there doesn't mean it can't be done. It can be, but what I'm going to do is I'll show you the steps. So we can't do the conversion directly from this drawing. So what I'm going to do is I'm going to create a new drawing. I'm just going to call this points. So now we've got a new drawing, and what we need to do is we need to attach that drawing which we saw just now. This is the use of the workspace on the left side. Okay, under drawings, I'm going to attach 2D points. Okay, you can see 2D points here. And what I'm going to do is I'm going to extract information from that drawing. Because it's possible that drawing may have a lot of other garbage inside. Maybe you've got other contour lines, even other text like words sekolah, rumah, that you don't want to put into your 3D points. So this is the use of query card. We're going to use the current query. This is to basically filter out the information, to extract certain information from the attached drawing. I'm going to call out only the text values. That means only the text. If there are any lines or circles or blocks, okay, they're going to be ignored. I only want to take the text. And from this text, we're going to create an XYZ text file. I'm going to use report. I'm going to go to options. This is where we set our report template, meaning like what's the first column, what's the second column, what's the third column. So I'm going to go to expression and extract x1. Add. So we've got our first column. Then I take the second one, that's y. So we've got x and y. Now the third one, I'm not going to take z because if we take the z value of the text, we're actually taking the absolute value of that z, which means, for example, if the text was placed at 0, we're going to take 0, which is pointless. We don't want that. What we want to do is we want to take the text value. If it's 44.59, it's going to appear as 44.5. That falls under the property string.
String?
Yes, it's under string. So we're kind of cheating here. We've got x and y, and string, when later when we import this, we're going to specify this as z instead. Okay. And of course, you notice OK cannot be selected, so we're going to output to an XYZ file. It's called points.txt. Click OK and click execute. Okay, so now we've got a report file. I'm just going to go to Windows Explorer to show you the file which has been created, points.txt. Okay, you can see this is what it looks like. We've got our X column, okay, our Y column, and this is the string column.
This is for lambda stop tree also.
Yes, lambda stop tree also. So when we import this, we just go to points, import points. And this is where we specify the format of the file you want to import. For lambda stop, this is the list of default format that comes with the program. ENZ, for example, stands for Easting Northing Elevation. We've got comma delimited space limited. This delimitation just means what separates the one column from another. In this case, it's a comma. Sometimes you may come across
Just a space.
yes, just a space, or maybe a lot of space. So at least you can use space delimited in that case. In the event that you have a file that the format is not listed in here, you can also make your own format. For example, let's say you're company using MOS, and MOS does have a lot of text formats as well, right? So let's say we need to import that and you find, okay, the format is not listed in this list here. You can make your own format. You see, just click on the icon on the right side here, click add, use a point file, and this is where you can create your own format. For example, maybe the first column is something very unusual. I don't know, maybe like longitude, for example, or maybe latitude. So it's very free in a sense. You can make your own format. But for this particular case, it's really easy. So we're just going to use ENZ comma delimited. I'm going to browse to that file. Okay, I'm going to add this to a point group called OGL, on original ground level. I'm just going to click OK. And what it's doing now is it is converting that text file into Autodesk Civil desktop lines. I'm just going to zoom in to show you the points. Now, each of these objects are now a unique object called point object. This does not exist in AutoCAD, because in AutoCAD you have points, you have text, you have blocks. This is very unique in a sense that it's a civil point object. Let's say, for example, I just select this object. We can look in the properties window. Say this is a civil point object. That means you actually recognize this point is not just a normal point. It's actually a point on a surface which we can use for triangulation. So with a little bit more about this text, for example, this particular text, this marker, this cross indicates the position of the point. This blue marker here. The yellow text indicates the point number, the red indicates the elevation value, and the green color represents any description you want to attach to the points. Yeah. Let's say, for example, the surveyor goes to field and he indicates, okay, at this particular point there's a tree here, or there's a drain or road line, wall. You can attach that kind of information in here as well. So at least you're not just looking at things and you don't know these points and you don't know what each represents. Just to give you an example, I'm going to edit this point. Say I write here, okay, there's a tree. So I'm just going to write tree. Click OK. You can see how the word tree automatically appears. So now we've got our points, and I'm going to run the triangulation now so you can see this in 3D. I'm going to go to Terrain, go to Terrain Model Explorer, and I'm going to create a new surface. So each surface is basically like a new level, for example. Let's say if I call this OGL, original ground level. So this indicates this is going to be the original level, the existing surface which the project looks like. So you can see there's no data here, so I'm going to add in the points. I'm just going to right click, add point group, add OGL. Okay, and I'm going to build. Running the build just means I'm running the triangulation. So we're done building surface. I'm just going to close this. Okay, at the moment you find there's nothing added to the drawings because in LandDesktop it's run on a project basis. So although everything has been updated, it's saved in the database, it's only loaded into the drawing on demand. Like let's say now we say, okay, alright, I can't see the triangles, I want to see what the triangles look like. So we just go to Terrain, say I got a service display, I'm going to use quick view. This quick view basically just, we can see the triangles only as a temporary preview. You can see the triangles now, but if I redraw, okay, it disappears. Now let's say we want something a little bit more permanent. We want to have the triangles stay there and we view them in 3D as well. We can use 3D faces. So I'm going to click OK. So now even if I redraw, it's still there. So I'm just going to show you what it looks like in 3D. Say I give a shade here, so it's a little bit clearer. You really see the lighting, how the light falls, how the light shadows fall. I'm just going to put this in 3D so you can see. Okay, this is what the surface looks like. And in this way, at least you can verify, okay, has the surveyor done his work properly? Maybe he made some vital errors on certain places. This is way you can verify the information. And also as an engineer and a designer, you kind of get an idea, okay, well, how I should put the platform, how I should put the roads, for example. Aside from triangles, I'm just going to set this back to 2D. And I'm going to switch off the triangles. I'm calling out the layer manager, and you can see that they've already created some layers for me automatically. I don't have to create the layers myself. The use of this, of course, is that then they actually put everything in their own layers, so you don't have to fret. Like in AutoCAD, let's say if you're doing a drawing of a building, you have to create your own layers, a window layer, make sure all the windows are on this layer, the doors are all on this particular layer. You put one on the wrong layer, you lose something for you. But in this case, because everything is created automatically for you, you don't have to worry. Say if I freeze the SRF-view layer, that's the triangle layer that's proposable. I'm going to switch off the points as well because it's a bit distracting. So remove all the points. So although they've been removed from the drawing, because they're in the database, it doesn't mean they're erased. They're just not visible in the drawing. Okay, I'm going to create contours. Okay. You can see the values have been inserted for me automatically as well. Elevation range from this level to this level automatically for me. You can set intervals at minor and major, minor only, or major only. I'm just going to click OK. So yes. You can see the contours have also been automatically created for me. Again, these layers have also been created on their own layers. So let's see if I want to change the color. See the major lines, I put them as green. Switch minor maybe to red. More visible difference. So you can actually see the contours minor and major. Again, they are also in 3D. So if I orbit, you can see them in 3D. Because it's not so apparent as the triangles, but you can still see them in 3D. So I'm just going to reset the view back to the top plan and zoom into the contours. A bit about the contours. One problem with these particular contour lines is that they're all very jagged, very sharp edges, and you may want to make them smoother. In normal AutoCAD, you would probably have to, fillet them yourself, and it takes a lot of time to do all that. Draft process busy, whole day busy just trying to fillet everything and smoothen everything out. Now, Blender Stock does have a Contour Style Manager in which you can change the contour appearance. Okay, we can look at the preview here. Okay, smoothing options at the moment, no smoothing means it's completely sharp. Add vertex. When you add vertex, you can see, maybe it's not so clear, but you can see that the edges are a little bit more rounded. Or you can use spline curve. Spline curve just means it's round. So let's see if I use spline curve, I'll just hit OK. You can see how everything has really smoothed itself out. Okay, without any adjustment at all. You just use the different kind of style. It really changes the appearance. And another problem with these contours is that you find there's no text whatsoever. You have no idea what each contour level is at. You can use the contour labels. I'm going to use group interior. Okay, and I'm just going to draw a line right through. When you zoom in, you can see the text. The text can also be adjusted. Let's say if you look, okay, I don't want so many decimal points, and I want a box around the text. You can go back to the Contour Style Manager. That's under Text Style. Precision is the number of decimal points. So I'm going to drop this to 0. And maybe I want to draw a border or label around the corner. I'll just click OK. It will be updated for me. And the text, right? If let's say you need to move the text, say I just select this contour line, just to point out to you, this is a civil contour object, not a polyline like in AutoCAD, not just a 3D line or anything like that. This is a contour object. You can see that marker has also been selected together the contour line. If I need to reposition this text, maybe sometimes in a drawing you have the text overlapping boundaries of your platforms, for example. You can just click on this marker and you just drag. I'm going to zoom out. You can see no matter how far I drag my cursor away from the contour line, the text still follows the contour. So this is about contour lines for Autodesk Land Desktop. Just to give you a bit more about the display, aside from the triangles and the contour lines, there are also many different ways in which you can represent the surface. I'm going to show you one which is quite unique. This is surface elevation shading, meaning I'm going to color the surface based on the elevation ranges. This number of ranges 5, so I'm going to click auto range. Okay, and what it is it automatically looks for the lowest and the highest elevation points, in this case from 22 to 77. You divide this into 5 equal ranges for me, and each range is going to be on a different layer with a different color. So the lowest is between 22 to 33, and they'll be colored red, followed by 33 to 44, yellow, and so on. I'm just going to click OK. You can even put a legend if you like. I'm just going to click legend, so OK. You can see how the colors are really being shown. So red color indicates the lowest elevation, remember? Then followed by yellow, green, cyan. So the legend is just going to insert it here. So when you zoom in, you can see, okay, this is the legend which you can use. Color is red, this is the range, the percentage of the area, and what's the area total in square meters. This is also in 3D if I do shading and I orbit. Zoom in a bit so you can see more clearly. You can see it's also in 3D. Because the contours are overlapping the colors at the moment. So you see a lot of contour lines there as well.
This is under which command?
This is under terrain, surface display, bending 3D faces. We can try any of this later when during our hands-on like. We've got bending 3D faces, bending to 2D solids, average. They look almost exactly the same. It's just that they're using different kinds of objects. Like 3D faces and 2D solids are different, but when you look from the top, it's the same. Okay, just cover a bit more about Land Desktop. This is another very unique feature that's been developed since Land Desktop 3. Let's say I just draw a polyline right through. I don't even have to draw it as a completely straight line. I'm just going to draw it as a line goes through, like this. And I'm going to use sections. This is, let's say if I want to view a profile of the terrain. I'm just going to click this line. You can see the profile immediately. And if let's say I find, okay, I need to remove this line. I'm just going to use a normal AutoCAD move on this line, move it to a new position. You can see how it updates automatically. So this saves you a lot of time in terms of creating a profile, because a lot of people are still using a manual method, so you can imagine how long it takes. You just move the line a bit, you got to do this all over again. It's not only about moving, even if you just readjust the position of the marker, it also updates. So that's another quick section. Extend it in. So some of the other unique functions of Land Desktop, just to show you. Here we've got parcels and tables. I'm just going to zoom to a blank spot so that the triangles don't crowd what we're doing. I'm going to draw just a non-polyline here and say, okay, let's say for example we want to use this as a parcel. I'm just going to define from polyline and just pick the line. You can see how the parcel number with the area appears automatically. And this is very unique also because they have a Parcel Manager, meaning if let's say this is gone, like okay, I've lost the drawing or I accidentally erased it from the drawing, it doesn't mean all is lost. You can still call it back from the Parcel Manager. You can see parcel 1's here. You just click import and it will appear again. For labels, we have two types of labels. One is a dynamic label, another is a static label. So I'll show you dynamic label first. So let's say I just pick this line. You can see how the text automatically appears. Now what's so dynamic about this is that if I move reposition any of the points, let's say if I just move this here, you can see how the label automatically appears. Static is different in the sense that, say for example, I'll just draw a line here and use static label. If I reposition this, the label does not move. That's static label. So whether you want to use dynamic or static is completely up to you. So whether you want to use dynamic labels or static labels, it's completely up to you. Some people like to use dynamic labels because at least they know, okay, if I make any adjustments, the labels are automatically updated with the line. Some people want to use static in case that they say, what if I accidentally move the line and I don't realize it? Because when you move the line, the dynamic labels follow the new position, right? But sometimes it's a mistake. So some of them, they say, okay, leave it as static, so in case I move the line by mistake, they can see, oh, this doesn't match up. I might have made a mistake here. So at least they can correct it if they need to. Yeah, let me show you some of the other major features of land desktop before we go to Civil 3D. Because land desktop is very powerful for earthwork calculations as well. I'm just going to switch off the layers so that we get left the contour line. So at least we kind of know where we're looking at. I'm going to create a proposed level here, like a platform, so that we can run our volume calculations. I'm going to zoom into this blank spot. Okay. And I'm just going to draw a platform here. Not sure what level this should be. So let's say I just want to check what is the elevation of my existing ground. There is a very unique function here called track elevation, which you look at the bottom here, instead of coordinates now, it's been changed to ELEV, elevation. And just by moving my cursor, you can see how the number changes. That indicates the elevation of the original ground level at where my cursor is. Okay, so now we see it's about 30 odd, 20 something, 30, 40 something. Okay, so I'm going to put this platform perhaps at 35. I'm going to use, this is a very simple platform, so I'm just going to draw a square, say 35 meters elevation. I'm just going to define this as my proposed level. Okay, no slopes, nothing. I add this in as a break line. Just build this. Okay, so now we already have a platform. In fact, if you want to check the sections, we'll use the quick section tool as just now. I'm just going to select this. You can see now you can see more than one profile. You can actually see up to a maximum of 8. See if I go to view properties, you can see you can see up to 8 different surfaces in the same profile view. So now we're going to run the volume calculations. In land desktop, we have 3 methods of volume calculations. One is the grid method, which is the normal manual method a lot of people use. They basically divide the drawing into grids. So the grid size, of course, is totally up to them. And what they do is they take the difference in elevation of each corner, take the average, multiply it by the area, and they total everything up together. That's how we get the volume calculation using the grid method. Okay, that's a grid volume method. The second method is a composite method, which can only be done by the software. It's not possible to do this manually. So a lot of people also call this the Dtm method. Dtm stands for Digital Terrain Model. So this takes a direct comparison from your original ground level to your original level to your proposed level, and you get the volumes from there directly. The third method is the section method. Section method is another very popular manual method where they basically cut cross sections across both the existing and proposed level. They take the difference, multiply it, and they total everything up together, they get the volumes from that. So I'm going to show you all 3 methods and show you how easy it is to use. First, we need to specify our stratum. We specify, okay, which is our original level, that's surface 1, then which is our proposed level, surface 2. Okay. And then next we need to define our site, because sometimes we have such a big area, we need to specify, maybe we only want to do the volume calculation for one small area. So this is what the site definition is for. Okay, so I'm going to specify this my base point, which is the lower left corner of the area. Specify your grid size. This depends on your project, of course. Every project has a different grid size. And this is the site which you're going to use. Okay. Now we've defined our original and our proposed level. We've defined our site. Now to run the calculations for grid, it's very easy. You just need to pick calculate total site volume. Select the site. Okay. Here, this is where you can do any volume correction factors if you need to. Like an actual project, usually for fill factors, you must put a little bit higher. You have to take into account, let's say when you import the solve, whatever you import is not necessarily how much is used to fill. You have to take into account the compaction, the settling. So let's say it's 20%. I'm going to put, say, 1.2. Of course, you can always adjust that later. I'm just going to call this grid. And the volume coefficients appear at the bottom. So I'm going to open up the history to show you. So this is our cut volume, our fill volume, and our net volume.
This is for the platform.
Yes, that's for the platform. For the second method, it's almost the same. You just pick calculate total site volume. Okay, pick the site. And again, you can specify your fill factor. So I'm going to put it the same as just now at 1.2. Okay, again, I'll call up the history. You can see our cut volume, our fill volume, and our net volume. The third method, using the section volumes, it's a bit different because we can't run the volume calculation straight away. We need to sample some sections first. So this is what I'm going to do. I'm going to sample some sections. Just hit OK. So it's sampling sections across my original and the proposed level. And now we run our calculations. Just click calculate volume total, select the site. And as you can see, actually within the section volume method, there are two further methods. One is an average and area method, and both are postmodel. These two fall under the section volume method. So I'm going to set the fill factor at 1.2, and we're going to run the average and area method first. So I'll click OK. Here you can see at the bottom, this is the volume calculation, cut, fill, and net volume. We're going to run this one more time, now using the postmodel method. It's out. So this is the cut volume, fill volume, and our net volume. So of course, looking at it in your text window history and you're going to write this down is very troublesome. Okay. So what you can do is you compile a summary report. So you start the report. See, this is where you can, again, do any correction factor adjustments if you need to. If it's a 1.2, you're going to put 1.25 or 1.5, you can set them here. We're just going to leave this as is, hit OK, and this is the summary. So you can do a comparison between the grid method, composite method, and area method, and the postmodel method. So this is the cut volume, fill volume, net volume. F indicates an excess of fill. You can see the values are, more or less, maybe the grid is just a little bit out. The other three are about the same. So by using these different methods, you can, at least be sure that the values you have are, you can compare the values. If you need to print this out, you can click print to file. It will put them into a TXT file. Just want to hit OK. Right. If let's say you need to generate any drawings based on those volume calculations, for example, you want to have grid volume ticks. Just going to go to grid volumes. There's an option here, grid volume ticks. You just click, okay, and you specify what the interval is between each tick. I'm going to use an interval of 10. Click OK. And I'm going to zoom in so you can see the values. So this is more for you print a drawing like this and hand to your contractor. You print a drawing like this for your contractor, so at least they know, okay, how you're going to level out the existing area. So plus indicates, of course, fill, and minus indicates the cut. So that's your grid volumes. For sections, if you need to generate any section drawings or section reports, you can click, say, plot all. I'm going to plot all the sections. I'm just going to put them somewhere here in the drawing. Because what it's doing now is it's generating all the different sections. That's why it's blinking like mad. The interval which I have set is dependent on the grid value which I put in during the site definition. In this case, I put 1. So if I zoom into the sections, you can see that each interval is 1 meter. So it can go as small as you want, but of course,
1 meter from
the 1 meter intervals. These are 1 meter intervals between each other. At the moment, there's no because it's taken 1 meter from the border.
1 meter from the border. It is horizontally or vertically?
or you can actually set the value in this case. Let's say just now the section. Here, you can set which direction you want. In my case, I set it as N. That means it's actually running vertical from here. It cuts across this way. Okay, let me adjust the color of the. Adjust the color of the layers. See again, they've got their own layers. So OGL, I'm going to put it as green. My PL, I'm going to put it as cyan. And the grids, I'm going to use dark gray. So this is easier to see. So you can actually see sections. So you can use this for, for plotting. This is for the section drawings. Now, if you need the volume calculations by section, you can also generate it here under volume report. Okay, let's say I use the Parcel Method. I'm just going to hit OK. And again, now it's generating the text file. Calculations are done. We're going to go, it's placed in here under the file name output.prn. Just going to rename this to sections. And we're going to open that up so you can have a look at the section report. So again, it's by every 1 meter. And you've got the cut area, cut volume, fill volume, cumulative volume for cut and fill, and your mass ordinate. Mass ordinate is basically cut minus fill. So you notice that Autodesk kind of puts everything into an ASCII text file like this. They don't export it to a very specific file. They don't export it to Excel or Word or even Lotus, because they understand that every customer may be using a different kind of solution. Maybe some companies will use Microsoft, some companies are using Lotus, some companies are using something else completely different. At least in this way, they know everyone is able to read this particular ASCII text file. You just open Notepad and you can read it. Then you export this into Microsoft Word or Microsoft Excel. And you adjust, put your company logo here, pretend you did all the hard work doing the calculation. And then you sign at the bottom, Show you the watershed boundaries. This is under the Terrain Model Explorer. You just right click and not right click. You open up OGL, you go to watershed and you right click on watershed and calculate watershed. This basically calculates the catchment areas of the surface. So you can see all these watershed IDs. If you want to put them into the drawing, you just click import watershed boundaries. These are the layer names. I'm just going to minimize this. You can see some extra white lines. So this is actually the watershed boundaries that have been imported inside here. They have assigned numbers. Let's say like 14. If you need to find out which one is 14, what is the which is 14? Let's go to 14. It tells you, okay, this is the area for watershed boundary. Number 14. There are even some which will tell you, okay, drains into which watershed, what's the area, what's the volume and flow. It's really all completely here. This is based on your triangulation, of course. Okay, I think that pretty much covers almost all the major points of Land Desktop. I'm just going to close this and open up Civil 3D. Okay, so now we're going to Civil 3D. Just to give you a history of Autodesk Civil 3D compared to Land Desktop, because we've used Land Desktop before, so just let you know that Land Desktop and Civil 3D, they're similar but not the same. The functions which exist in both Land Desktop and Civil 3D are very similar. Like all these volume calculations, Civil 3D can do as well. Civil 3D takes a step further by being able to do road design. This 2005 version doesn't have it. 2006 has pipe layouts as well. Last time Land Desktop, you can only do volume calculations with Land Desktop, but all these additional things like road design and pipe design and hydrology is done with an additional module called Autodesk Civil Design. In fact, even Civil 3D is very different from Land Desktop. So you find a lot of things similar, but the way you do it is quite different. So the reason why Autodesk came out with Civil 3D, because of course a lot of people are wondering, you really got excellent software like Land Desktop and Civil Design. Why bother coming out with a totally different package called Autodesk Civil 3D? But this is because now Autodesk Land Desktop and Civil Design, they're running on Autodesk engine, which I mentioned earlier. So it's not really their own, and it's very hard to modify anything inside that engine. And the problem is because over the years, the land desktop and civil design users, they've requested for a lot of things. Of course, Autodesk does have a wish list. When users say, okay, why can't you make this software do this? Or can we make the software generate this kind of report, for example? And these are called wish lists if Autodesk land desktop cannot comply. So the thing is, like Autodesk, they hear you, the users want this kind of functions, but they somehow can't make land desktop and civil design created. They can't generate the output that they want. And I think we tried it for quite a number of years without success. So in the end, they said, okay, let's just forget about it. Let's make a brand new software from scratch in which we can actually implement these functions as we go around. So that's how they came up with Civil 3D. Because of this, they look at land desktop, okay, these are the functions we want to retain inside Civil 3D. So you find the functions are same. Functions are, similar, but it's just that the way you use them are quite different. So one of the major differences between land desktop and Civil 3D is in the platform that they use. Land desktop uses projects. Like just now I mentioned, you can only open one drawing at one time. If you lose the drawing, it doesn't matter. You can always call the information out again because it's all based on the database. So in Civil 3D, it's like AutoCAD. It's drawing based. You lose the drawing, that's it. It's gone. But the advantage of this is that at least you can be very sure. This is my latest drawing that I have. This is because then it's a lot. It's not so heavy on your computer as well, because you don't have to worry about all the different files. Like if you go into land desktop, say for example, this is my land projects. These are all my different projects inside, which have been created using land desktop. Like in this particular project, these are all the different files and folders that have been created using land desktop. This entire folder indicates the project database. So when you want to back up your project, you want to back up everything inside here. Civil 3D is drawing based, so the only thing you need to do is just back up that drawing. And another major difference between Civil 3D and land desktop is that Civil 3D is very much object oriented. Like land desktop is just project based, right? But Civil 3D is object oriented, meaning let's say if you move anything and you move the horizontal alignment, the vertical profile is updated at the same time. So what I'll do is I'll just show you what it can do. Instead of starting from scratch, I'll open up a drawing which I already have, just to show you the major difference. Like the bit about converting 2D to 3D can also be done in Civil 3D using the same methods, because actually Civil 3D comes together with maps. So you can see the squash at the bottom here, there's a workspace. Yeah, you can use that to create convert that 2D to 3D as per the land desktop method I showed you just now. So I'm just going to zoom in so you can see these are actually all the points. So the points, are about the same as in land desktop. And I've already created the surface connector. So Civil 3D, it's unlike Autodesk land desktop. Like land desktop, to create contours, to create the elevation banding, the triangles, you have to go to just now terrain and then you create yourself. In Civil 3D, there's no terrain option here you find. Everything is managed on the left-hand side. On the Prospector, this Prospector basically contains the data that exists inside this drawing, like points. Okay, we've got all the points. If I click OGL, you can see all the point information here. The advantage to this is that it's a lot easier to modify. Like in land desktop just now, remember I wanted to edit a point description. Let's say in this case we've got P here, 1248. So for 1248. Okay, if I want to modify the description for this, like just now in land desktop I want to go to points, edit points, modify, and so on. Here all I need to do is just click on OGL for that point, let's say P, change this, let's say I put 3. Okay, modify it, right? Yeah, it's updated. It's just by clicking, it's very much faster. Okay, we've got the surfaces in here, my OGL, my platform, my sites, like the terrain calculation, corridors and so on. So all the data is managed in the Prospector tab. Okay. Now the bit about contours and the triangles that we want to generate from the surface, it's very much different from land desktop in the sense that you don't have to create it. where when you generate contours, you want to go to terrain, create contours, select the attributes, and what's your interval and all that. We don't have to do that in here. What we need to do is set the settings in here for Civil 3D. We still need to specify what the intervals are for our contours. Maybe you want to specify what the colors are for your contours. But that falls under settings. Let's say the settings, surface styles. We've got quite a number here actually, but borders and contours. Maybe I'll show you the difference between all this. I'm just going to zoom out. I go to OGL, right click, go to properties. And this is the surface style, meaning how we're representing the surface at the moment. Right now we're using contours background, so it's barely visible because it's all grey. Let's say I switch. I want to see borders and triangles and directions, and I click apply. You can see how it's updated automatically at the background. Now these are all the triangles, colors. If we want to see another one, say I try slope arrows, apply. Now they've used, see the contour lines have changed color and there are slope arrows. I don't think you can see it. So I'm just going to zoom in so you can see the slope arrows that are coming about. Still being updated. Okay, these are the slope arrows. The slope arrows basically indicate how we are going downwards this way. So this is very different from LenderStop. Like LenderStop, you got to create all this yourself as you move along. With Civil 3D, no, you just set the settings and you just need to modify and say, okay, instead of seeing the slope arrows, want to see the points, you just apply. It will update for you. So it's lighter in the sense that you don't have to load them into the drawing. You don't have to erase them, switch out the layers, none of that. You just need to play around with surface styles. And these surface styles you can create your own as well if you want to be very specific. Instead of a 1 meter interval for contours, you want to set 5 meter intervals. You want to set different colors, different names of the layers for the contours. Everything is completely customizable in Civil 3D. Now coming back to the object, what we call the dynamic abilities of Civil 3D. I have already created a road here. We've got a horizontal profile and a vertical profile. We've even got some cross sections in here. So I'm just going to say click here, so get hold of my horizontal alignment. I want you to look at the vertical. You can see the vertical has been adjusted automatically. So this is very different from LenderStop and Civil Design. Even though you've never used Civil Design, just to let you know, Civil Design is kind of like LenderStop. When anything has been done, you need to reprocess everything. You need to reprocess what the sections are, where the position of the new horizontal alignment is. In this case, you just need to move and everything's updated from. So this you can be very sure in this sense that it is the latest information. The only thing here that has not been updated is the corridor. The corridor that I'm talking about is sort of like a 3D model of the road, because this model has to be generated. It's not, it's not reliant. It's not directly connected to the horizontal and vertical, as you can see. But it's really very easy to update. See, it says it gives you a warning, hey, this is not updated. Just right click, rebuild. And you wait, and you wait, and you wait.
The shoulders.
Yeah, because let's say we've already done our final cross sections. This is the sort of 3D model of this. So it's been updated. So you can see it's already been repositioned. So just to show you this corridor bit, if I select this, you can see it's all one object. Even if I select the surface, it's all one object. Because now they're not separate entities, they've made this all one object so that it's a lot lighter on your computer and drawing. So let's begin now. So this is the corridor has been created for this project. And I'm just going to select the corridor, look at the object viewer. Hope it works. The object viewer basically is for you to view the object. They've got all these zooms and the shape and the orbit. This is an advantage in the sense that with AutoCAD you also have all the orbits and everything, but you orbit and you view everything in the drawing. with the object viewer, you can just select one object. I want to see what this looks like. So it's a lot easier to check what has been done. Okay, so this is the 3D object. Okay, it's gone all the way down to level 4. I think this is slow. Sorry, this computer is not very good. It's gone. Oh, here we are. Now I'm gonna zoom out. I'm just gonna wait a bit. Yeah, but at least by using the object viewer, you can see the object visually. I think I've zoomed out a bit too much, but I think you kind of got the idea. Because I'm using the scroll mouse to zoom, so that's why it doesn't update automatically. So this is the road, or this is the corridor. Another splendid thing about Civil 3D is that it also comes integrated with the Autodesk Viz render. You heard of Autodesk Viz? Viz is, have you heard of 3ds Max? Okay. Just to give you an idea, the Autodesk Viz and 3ds Max, they're actually very closely related. They're more for, like 3ds Max is more for animation. Like, all those cartoons that have been created, using Incredibles, they use 3ds Max to generate the animation. This is sort of like the light version of 3ds Max, but it's used very commonly by interior designers. Let's say, okay, we've got this room, we've got a window, okay, and you have all these tables. You can actually render material, meaning, okay, this table I want to put a wooden finish or a marble finish. It can generate that material for you, and also you can play around with the lights. Let's say lights are coming from all these light fixtures, or if you have sunlight coming in through the window, what does the room look like? You can use this to play around. Of course, Civil 3D does not come with that wonderful package of Autodesk Viz, but it comes with what is useful in Viz for civil engineers. So we call it Viz render. We've got a corridor here that we want to see what this looks like in maybe if you put the asphalt on top, maybe you've got the grass at the side, you want to see what it really looks like. That's what Viz render is for. So you just click link to Viz render. I'll show you the grading bit. Let's say I have a platform here. You can just, if you like, you just draw a platform anywhere here. Okay. So now what we're going to do is we want to grade. We call this grading in Autodesk. We want to grade this platform down to the original ground level. But first we need to specify what's the elevation, right? Now we do that during grading. Okay, just go to the grading menu. Go to grading layout tools. Then you have another floating menu on top of it. Okay. So first we're going to modify the elevation. So we go to the grading elevation editor. Okay. And then it'll ask you select the feature. It asks you to select the feature. So just select the white line. Okay. And then it'll ask you convert the selected entities to feature lines. This means because for grading, you need to use feature lines grade instead of normal polylines. Yeah, so what it does is it will convert this for you. And so you just say yes. So a window will appear. And this is where you modify your elevation. So let's say we want to make this a flat platform. So I'm just going to click first line, hold shift, and then select all the way down to the last line. So to modify the elevation all at one go, you just click anywhere inside the elevation. Okay, you see everything else has been grayed out. Then you just type in here. Let's say if I type in 35 meters, hit enter, you will find that all the elevations have been switched. right? And then we just click the check mark to say, okay, yeah, dismiss this. So now we've got a feature line at 35 meters in this drawing. What we want to do is we want to grade this platform to the original ground level. So first we need to set the grading group. So we select the first icon. So this, by default, they always will display, let's say, the name of the object. In this case, it's a grading group. Next counter means they run a sequential number. In this case, grade group 1. The next one will create a grade group 2, then 3, and 4. So we'll just say, let's leave this as is. If you like, you can create a surface automatically on this. Meaning, you know, like the proposed level, instead of creating our own surface called proposed level, then you say, okay, I want to use this grade inside this. You just click automatic surface creation. It will create a proposed level for you automatically from this grade. But the name of the level, the platform, of course, will be called grading group 1. Okay, so that's why we say use the group. Surface style, you can also give it a try later. Maybe I'll just leave this as standard first. Okay, and I'm going to click OK. So this is the surface grading group 1. Okay. So you'll find now that we have grading group 1 and surface is OGL. Okay. Next we set the target surface because we want to provide slopes from this platform to the original level, right? So just in case you have more than one, you need to specify what's the target. So in this case, it's only one OGL. It's fine. Now this is if you need to set the grading layers if you want. This is by default for this template. This is fine. So cancel. And now we're going to select a criteria set. So just to show you, you don't have to try this out. Just to show you the grading criteria set. So this under grading, there's under settings, beneath grading, there are 3 options here. Grading styles just mean how we represent the grading. Let's say like if we want to have a look. Okay, this is what it looks like. This is what the slopes will look like. So this is just the display. So that falls under grading styles. That falls under grading styles.
Is it standard style or?
Oh, you can edit. You can edit yourself. I've tried editing before also. So I just click. Like let's say if you want to take away the triangles, for example, you can just drop. Say I don't want anything. So take away your triangles. You want to make the line longer? Okay, that's increases up to 50%. Completely customizable. I'm just gonna leave this as is. So grading styles is for the display of your slopes. Grading criteria sets is how the slopes are defined. Okay? But sometimes you can have, of course, if it's daylight, you want the cut or fill from the platform to go all the way up or down until it finds the original ground level. In some cases, you may want them to go down to a particular set elevation, maybe to an absolute elevation of 30, for example, or you want a relative distance of maybe 1 meter, something like that. So this is what the grading criteria set is for. It holds all that kind of information. So these are some of the sets that we have. So for us, if we want to have it go all the way up or down until it finds the original ground level, that falls under surface slope. So this is just to show you. So I'm going to switch this. I'm going to switch this to basic set. Because standard set has only standard, it's got like nothing in there. Okay, basic set is the one with the distance at grade, basic set slope. You just click here on this icon, switch this to basic set. So once you switch this basic set, you'll find this drop down list is exactly the same as what's in your settings. So I'm going to set this at surface at slope. Surface at slope. Now we go to the next icon.
Slope surface at 2 to 1 slope, right?
Yeah.
That means
that the slope value is
slope gradient.
The slope gradient. So this is quite good in the sense that it's quite easy. Like you just go from one icon to the next. So after we finish this, we click on this one now. Create grading. So we create grading. Okay, they'll ask you to select the feature. Select the polyline you've created. Select the grading side. That means you want the slopes to go on the outside or the inside. If you want it on the outside, just click anywhere outside. As long as it's outside, just click. and they ask you apply to entire length. Do you want the slope to be along the entire length of the platform? So let's say yes. And then they'll prompt you, okay, what is the cut slope? So let's say I put 1 to 1. Fill slope, say I want to 2. And that's how they create the slopes. Now this command in Civil 3D is quite, it's very good because it updates automatically as well. I'm just going to zoom out a bit so you can see. And I move this to a new location. Notice how the slopes also adjusted to the new location. Okay, I'm just going to run through the volume calculations quickly with you. Okay, so just click on volume. Then this composite volume window appears. This uses the composite volume method, which is very easy to use. Okay, we start off with the first icon. Click create new volume entry. So what you get is a line underneath here. So all you need to do is just specify what's a base surface, what's a comparison surface. Base surface means which is your original level. Okay, so let's say we select OGL. And then comparison surface, I'm going to select Learning Group 1. You just click anywhere outside, it does a calculation for you on the machine. Right? Learning volume 2, so that it will appear here. Now, this button here automatically raises lower to balance volumes. Just select it. So this is where we put in what the final volume we want is to be, so that it will do the balancing for us. Okay, so if we want the cut and fill to be equal to each other, the required volume then you type in as 0, so it's equal. If you want more fill, you put a positive amount. If you want more cut, you put a negative. So let's say we put it at 0. I'm going to click OK. So then it automatically adjusts it for me. So you can see this is the history. That means initially, the first time it was this much. After that, they balanced it. We got this much of cut, this much of fill. Our net volume is maybe 1.47 cubic meters. And it even explains to you what happened. See, description: auto balance lower group. So this is where you can balance the volume, raise or lower the platform. So this is for